Hello students, today we are going to discuss about motion of a projectile along inclined plane. So here the first case is down to top. That means the projectile is thrown from the bottom of the inclined surface to top. So here this is an horizontal surface. So this line is inclined surface which is making an angle theta with the horizontal. Got it? Now the object is thrown in air with a given some initial velocity u, so which is making an angle alpha with the inclined plane. Okay, already I told you the inclined surface making theta with the horizontal, and the object which is thrown from the bottom to top, no, which is given some initial velocity u, which is making an angle alpha with the inclined surface. Now this will be having two components. So the initial velocity which we are given, along horizontal direction, that means along the inclined surface, the velocity will be u cos alpha, that is horizontal component of the initial velocity. And then the vertical component, okay, here you see this is the vertical component of the initial velocity, that is u sine alpha. Got it? What is this one, sir? This is nothing but the gravity which always acting in downward direction, which is making an angle theta. Okay, so this will be adjacent side, since it is below the origin, no, so this will be called the adjacent side of the component will be minus g cos theta. Got it? Now this will be horizontal component of acceleration. So this is along the inclined plane, but left of the origin, so that it will be minus g sine theta. So we have discussed the horizontal projectile motion and angular projectile motion. We have discussed throughout the motion, the horizontal direction, there is no acceleration. But here in the inclined plane, since it is inclined plane, there will be an acceleration, both horizontal direction as well as vertical direction. Okay, because the weight of the body always acting downward direction, which makes an component along horizontal as well as vertical. Got it? So here, since it is adjacent side, we are making g cos theta, but it is opposite, no, so opposite to y axis, so that we are making minus g cos theta. This is left of origin or negative x axis, so that we are making minus g sin theta. Got it? So what we are going to find out from this? So we can find what is the time the projectile will take to reach the bottom. Bottom means, for example, if you are thrown in air, no, it will be reach the top. So from the bottom we have thrown the projectile by giving some initial velocity, then it will be hit somewhere the top of the inclined plane. Got it? So what is the time it will take? So we can find time of flight. Okay, and then we can find what is the range covered by the projectile from the point of projection to where it is hitting the top of the inclined plane. Okay, so that horizontal distance only called a range. Okay, and the time duration from the point to hit, this is only called a time of flight. So during the journey, what is the maximum vertical displacement attained by the projectile? Okay, so that only called a h maximum. So we can find all these things. So for all these, we are going to use the basic equations of motion which we have already discussed in this chapter. Okay, the first thing, velocity equation. So v equal to u plus at. After that, position time. So s equal to ut plus of at square equation we will be using. And then the velocity and the position time graph equation is there, no, v square minus u square equal to 2as. So these are all the three equations we already used in equations of motion. So here to find h maximum and time of flight and range, you will be using any of these equations. Got it? Now, first we are going to divide the question into two parts. So first thing, as I told you, velocity component and both horizontal as well as vertical, we knows that in horizontal direction the component of the velocity. So first I will write along x direction. So along x direction the velocity is u x equal to u cos alpha, and acceleration ax equal to minus g sin theta. Got it? So this is along x direction. So likewise along y direction the velocity will be uy equal to u sin alpha. Likewise, the acceleration along y direction is minus g cos theta. Okay. So with the help of this, we can easily find the time of flight and h maximum and the range. Okay, as I told you, time of flight, time taken by the projectile from the point of projection at the bottom to where it is hitting the ground at the top of the inclined surface. So for the entire journey, what is the time it has taken? That only called the time of flight of the projectile. Got it? Okay, now first we shall find the time of flight. So TF equal to, what is that? So as I told you, equations of motions only we are going to use. So we are going to use the second equations of motion. Sy equal to uyt plus 1 by 2 ay t square. Okay, now Sy, what is that, sir? Vertical displacement. So here in the case, the particle started from the ground. Again, it is hitting the ground. So there is no vertical displacement. So that will be 0. And uy, that is nothing but velocity component along y direction. That is u sin alpha. And then the time of flight we are going to replace by tf. And ay, so that is minus g cos theta. And here also tf square. So here t is replaced by tf, that's it. Now since it is 0, no, so we will substitute everything in the equation. U sin alpha tf minus 1 by 2 g cos theta into tf square. Here plus, so gravity value is minus, no, so that here minus coming. Now if we rearrange this equation, we will be getting 1 by 2 g cos theta tf square equal to u sin alpha tf. So here we can cancel the tf and the tf square, and then you can cross multiply the 2 and g cos theta will be going to the denominator. Okay, now we will be getting tf equal to 2u sin alpha divided by g cos theta. Okay, so this is a relation for time of flight along the inclined plane from bottom to top. So here to remember in the exam, you can easily write 2 the component of velocity along y direction divided by the acceleration along y direction. So this will help you to remember in the exam time of flight. Okay, so going upward, ascent and descent, so that we are multiplying with the 2 and the acceleration. So easily you can remember acceleration equal to velocity by time. So that time we are taking left hand side, and g going to right hand side. So like that also we can remember. And then now we are going to find out h maximum. So h maximum already I told you. So what is the maximum height attained by the projectile? Okay, here you see what is the maximum vertical displacement, that is time of flight, sorry, from the point of projection to where it is hitting the ground, for that entire journey what time it has taken, that only time of flight. Maximum vertical displacement. Okay, so Vertical displacement here, this is H maximum. Okay, hello students. Now we are going to discuss about H maximum. So what is meant by H maximum? Maximum height attained by the projectile during its journey. So that means along y direction, how much height the projectile has reached. Okay. So now to find the H maximum, we are going to use V square equal to U square plus 2a S formula. Okay, V square. So at maximum height, the velocity will be 0. So what is the y component of the velocity? So that only we are going to use everything along y direction only we are going to use, because maximum height attained by the projectile. No, so for that. So uy in the place we can substitute u sine alpha, and ay in the place minus g cos theta, and sy in the place we can substitute h maximum. So now, if you substitute everything in this formula, you will be getting u square sine square alpha, because uy square is there, no? Then again, since minus is there, we will be getting 2g cos theta into h maximum. If you rearrange this equation, we will be getting h maximum equal to u square sine square alpha by 2g cos theta. Okay, so here also we can easily remember H maximum is equal to uy square divided by 2gy. So if you remember this, okay, already we have discussed in the projectile motion, angular projectile motion, H maximum uy square divided by 2gy. So you need to substitute only the component of the velocity and acceleration properly. You can get the H maximum easily. Okay, so first we have derived time of flight. Now we are deriving H maximum. So now we are going to discuss about range. So how to find the range? Okay, so here range. What is meant by range, sir? From the point of projection to where it is hitting the ground. For that, what is the horizontal distance covered by the projectile? So that only called what? Range. So range means what is the horizontal distance covered by the projectile? That only called a range. So to find the range, we are going to use the second equations of motion. So to find the range, we are going to use that formula along x direction, no? So that sx uxt plus 1 by 2 ax t square. Got it? So already we have found out. So range, horizontal distance only, range sx ux in the place we are going to substitute u cos alpha, tf in the t in the place t time of flight only we are going to substitute. So ax in the place minus g sin theta. Okay, now range equal to ux in the place u cos alpha into tf in the place 2u sin alpha. As I told you, time of flight not 2 into vertical component of the velocity divided by g cos theta, vertical component of gravity. So g cos theta minus 1 by 2 g sin theta into time of flight we need to square. So when you are squaring this formula, what will you get? 4. So time of flight here only we have written. So 4u square sin square alpha by g square cos square theta. Okay, now what we can do? So here you see, here also 2u, here also u is there. So you'll be getting 2u square. So here also 4u square is there, no? So we can take it 2u square sin alpha, we can take it outside. And the denominator you see here g cos theta, but here g square cos square theta. So here also we can cancel. So this g can be cancelled with the square. Okay, now we can write 2u sine alpha. You take it outside. So if you are taking 2u sine alpha, what will be inside? At the same time, so 2u sine alpha we are taking outside. So that means cos alpha will be there. And the denominator we are going to make it common. But here only cos theta is here. But the right hand side we have cos square theta. So here we can multiply with the cos theta both numerator denominator. So if you multiply, you will be getting cos theta divided by, you can write g cos square theta, because here we have multiplied, so the denominator will become cos square theta. Now numerator, since we have taken outside, so you'll be getting sin theta. So 2u we have taken outside, so what we will be getting? So these 2 and this 4 also we can cancel. Very good. Okay, next sin theta and sin alpha. So here this formula is seems like cos A plus B. So cos A plus B formula we know very well. Cos A plus B, you can write cos A minus cos B. Sorry. So you can write cos A plus B. Cos A cos B minus sin A sin B. So here you see cos A, alpha is there, cos B, theta is there. So alpha is A and beta. So we can rewrite this formula, range equal to 2u. So here we forgot to miss one thing, 2u square, because u into u square. Here also u square. So 2u square sin alpha into cos A plus B formula, so alpha plus theta divided by g cos square theta. But we no need to use this formula for calculating the range. Okay, so we can use this relation itself to find the range. Okay, because we know how to calculate the horizontal component of velocity and horizontal component of acceleration. The time of flight already we have been calculated, means we can substitute directly in this relation. Okay, now, so what are the things we have learned now? Time of flight. So time of flight formula is 2u sin alpha. 2 into vertical component of velocity divided by the vertical component of acceleration. So g cos theta. And then h maximum, that also u square sin square alpha divided by 2g cos theta. Okay, and then range formula. So range formula I told you no need to mark up. So okay, so we are going to use only range equal to u cos alpha into tf minus 1 by 2. So ax, so horizontal component of that only. So g cos, sorry, the horizontal component of acceleration is g sin theta into tf square. So directly we can use this formula to calculate the range. Okay, now we shall discuss one example question. So here you see, this is an inclined plane. Okay, here the object is thrown in air, which is making an angle alpha. Alpha we are going to give 45 degree. Okay, so here the inclined surface angle theta we are going to consider as 37 degree. So what is the velocity we are giving? So u equal to, for example, 10 root 2 meter by second, you assume. Okay, so for this case, what is the time of flight and what is the H maximum and what is range covered by the projectile. So we shall discuss now. Okay, so first thing, as I told you, we can find the components. So ux equal to, so this is the horizontal component of velocity, and here we can make the vertical component of the velocity uy equal to u sin alpha. So ux equal to u cos 45 degree, no? So u in the place we can substitute 10 root 2 cos 45 degree value 1 by root 2. So if you cancel root 2, we will be getting 10 meter by second. So similarly for y component u sin 45 degree. So here also if you substitute 10 root 2, here it will be 1 by root 2, no? So here also you will be getting the component of velocity along y direction also 10 meter by second. Okay, now we can find first time of flight. So time of flight formula 2u sin alpha divided by g cos theta. So you just substitute here 2 into vertical component velocity only we need to substitute here. So vertical component velocity is 10 and u sin alpha value only now we have found out that only 10, and then divided by g cos theta. So g value 10 into cos 45 degree. So cos 45 degree, sorry, here the theta means the inclined surface angle. So that is 37 degree. So here we can write theta in the place 37 degree. So cos 37 degree, how to remember, sir? So cos 37 means here. So here you see 37 degree. 37 na the opposite side will be 3. And the hypotenuse side for both 37 degree 53 degree, the hypotenuse always 5 only. So to remember 37 opposite side will be 3 only and the adjacent side will be 4. So 37 means adjacent by hypotenuse, no? So you will be getting 4 by 5. So here you can cancel. So here if you cancel the 5 with the 10, you will be getting 2. And this 2 will be cancelled. 10 by 4 means you will be getting 2.5 second. So this is the time of flight. Now we are going to find the range. So how to find the range? So before that we will shall find H maximum also. So H maximum formula is u square sin square alpha by 2g cos theta. Okay, so this is the formula for H maximum. So you directly substitute. So u sin alpha we have found out. So u square 10 root 2 whole square into sin square 45 degree divided by 2 into 10 into cos 37 degree. So directly you square this. So 10 if you square you will be getting 10 square into root 2 if you square you will be getting 2 into sin square 45 degree. 45 now 1 by root 2. So 1 by root 2 into 1 by root 2 divided by you will be getting 2 into 10 into cos 37 4 by 5 I told you, know. So now how we can simplify this one? So 2 will be gets cancelled and for this 10 this we can gets cancelled and this 5 goes to numerator, what we will be getting? So you will be getting a 50 divided by 4 into the root into root 2 will be getting 2, no? So 4 into 2 8. So here we can cancel this also. This 2 if we cancel will be getting 25. So in 25 we will be having 6 fours. 6 into 4 24. Remaining 1 will be there. So put decimal point. So we'll be getting 6.25 meter. So this is the H maximum. Okay. So with the help of this, now we can find the range. So range formula I told you. So range formula R equal to U x t plus 1 by 2 a x t square. This alone enough. So u x in the place u cos alpha into time of flight tf minus 1 by 2 g sin theta into tf square. So already I told you directly you can substitute. So u cos alpha we already found out 10 because u in the place 10 root 2 cos 45 degree into tf 2.5 second minus 1 by 2 into g value 10 sin 37 degree into tf square. So 2.5 whole square. So now you just simplify correctly. So 1 by root 2. So here 1 by root 2 means the root 2 will be gets cancelled, no? So now 10 into 2.5 will be writing 25 minus, here also we can cancel. So 2 if we cancel will be getting 5. So 5 into 3 by 5 sin 37 degree 3 by 5. I already told you. So here 37 degree mean here it will be 3. Hypotenuse always 5. Here it will be 4. So opposite by hypotenuse. So it will be getting 3 by 5. And 2.5 into 2.5 we will be getting 25 into 25 6.25 now. So we will be getting 625. So we will be getting 2 decimal points. So 6.25. This 5 will be gets cancelled. So now you just multiply 25 minus 3 into 6 18. So 18.75. So 18.75 what you will be getting? So the value will be 6.25 meter. So range also 6.25 meter we are getting. Okay, so once again, so first we have discussed how to find the time of flight. So time of flight we have used the second equations of motion. We have taken only the vertical components alone. So we have obtained 2u sin alpha by g cos theta. Okay, to remember easily, time of ascent plus time of descent divided by gravity. So 2u by g. And then we have discussed h maximum. For that we have used velocity and position time graph equation. So here we have assumed at maximum height the velocity will be 0. Okay, so by using the components of velocity and gravity we can easily obtain this relation. Okay, and then we have discussed range formula. Okay, range formula just for calculation we need to do this one, but when we are doing numerical we can use the this equation alone enough. So it will be easy for us to solve the numericals without making any mistakes. Got it? Okay, thank you children.